This experiment shows that an ionic salt will conduct electricity when molten, but not when solid. It also shows the products of electrolysis at the positive electrode and the negative electrode. The salt chosen is zinc chloride because of its low melting point of 535 K or 262 degrees Celsius. We no longer use lead bromide due to its toxicity and for the fact that it does have a tendency to decompose on heating without electrolysis. First of all, we set up the apparatus. For this, you'll need a heat-proof mat, a tripod, pipe clay triangle and a crucible. Ensure the crucible sits firmly in the pipe clay triangle and doesn't fall through. Next, we set up the electrode assembly. For this, you'll need 2 graphite rods, about 15 centimetres in length, the longer the better, and a bung or holder. Slide the rods into the bung and make sure the bung is as high up the rods as possible to avoid heating when we turn on the Bunsen burner. This is quite a fiddly procedure and we recommend that it's done before the demonstration starts. Now set up the electric circuit. For this, you'll need a power pack, an ammeter, set up in series with leads to the electrode assembly. Switch the power pack on and set a voltage of about 12 volts. Test the electric circuit to show you have a current. It is possible for the graphite rods to crack where they pass through the rubber bung. Suspect this if the circuit does not work and there is no obvious cause. Once you're happy that the circuit is complete, position the electrodes into the crucible. Make sure they go as far down the crucible as possible, but not touching the bottom. Now you need to fill up the crucible with zinc chloride. You should be aware that as the zinc chloride begins to melt, it will shrink in volume, so do make sure you've got enough in the crucible. Once you're happy with the setup, you can begin heating using a moderate flame on your Bunsen. As the zinc chloride melts, the ammeter will give a reading. Bubbles of chlorine will be seen at the positive electrode. We can test for chlorine using moist indicator paper, which goes red and then should bleach. An alternative test is moist starch potassium iodide paper, which you can see clearly glows black. The electrolysis may be carried out in a well-ventilated open laboratory. The amount of chlorine generated in 15 minutes of electrolysis is small enough to be acceptable in an average-sized, well-ventilated lab. Electrolyse the molten salt for about 15 minutes, adjusting the current to about half an amp. During this time there will be little to see, and it is best to get the class to go back to their places and do another activity. You could allow small groups of students to come up and see if they can see the bubbles of gas at the positive electrode and maybe smell the bleachy smell. After 15 minutes, you need to turn the power pack off, remove the Bunsen and take the electrode assembly out of the crucible. Allow the crucible to cool for some time. Once the crucible is cool, you can remove it from the pipe clay triangle and place it into a beaker of water to dissolve any unused zinc chloride. You can filter the contents of the beaker to reveal the metallic zinc on your filter paper. This will need to be dried and then can be tested using a circuit tester. Since the chlorine was seen at the positive electrode, it seems likely that the zinc was produced at the negative electrode.